So hello guys, some project updates. I will tell you what I'm working on besides the FT897 battery pack, 100 watts portable. This is a follow-up project from the screwdriver antenna. What I made, this is working really awesome. I don't want to miss it anymore. I just enter the frequency and the antenna drives to the resonant point. This is awesome. And this is a follow-up project. I'm using the same printed board. The only difference is I have here a rotary encoder. And yeah, completely different firmware. And the idea is to control via Wi-Fi a coil. And this coil could be used, for example, if you make a dipole, a shortened dipole, or for example, you have at home a special, you need to make a special antenna. For example, one leg longer, the other shorter. You not have you have only limited space. This could be very handy because then you can put the coils inside and adjust the coil with a wireless control unit. I will show you this. I made here a prototype. I'm powering this on. I will call this thing Coil Master 100 because this has 100 microhenry maximum inductance, the coil. And this is, by the way, all 3D printed. There is even the, how it's called, this thing here is in the middle, so what drives the coil. There is a spring-loaded contact, what makes a contact on the inside of a coil. And with this you will drive with a stepper motor. Here's the stepper motor. There's a different stepper motor. I choose the very flat one, what I found. They are quite cheap. I made here the prototype. So here you have Coil Master. What you see here, this is the battery voltage from this thing. Yeah, I had to resolder here some things because this is not battery powered and not with 12 volt. So, and if I turn this now on, this is here also, there's a Raspberry Pi Pico 2W. The great thing is this device has a Wi-Fi on it. And my screwdriver antenna, this is connecting to my home Wi-Fi network. But this thing here is, I changed this firmware is a different one. I create an access point. So when this powers up, it creates a Wi-Fi network. And this coil, when I power this on now, flip here the switch. This is powering on. And it will connect automatically to this Wi-Fi network. And you see here down the IP address of this coil. And he's sending, at the moment I'm flashing here the LED every half a second. He's transmitting the position of the coil. And I also have a lookup table and I know which microhenry this is. So if I turn here this wheel, on the top this is my position what I adjust here, and on the bottom this is the actual position of the coil. So the lower number is following always the upper number. So if I move this fast, he needs a little bit time to reach this point. Here you also see the battery voltage. The battery voltage of this battery here, because there is no display or something. So you need to see somewhere how full the battery is. And this is working so far great. The only thing what I really not like is this is getting too big. I mean, this is my prototype. I made this on this this is not really nice. So what I did, I put everything what is here on the printed board, and yeah, I've made a PCB board, and I also added a switch to detect the end of the to calibrate this coil, so that I know where is the end, and from here I can calculate everything. Because this here I not have a switch in this on this prototype, but yeah, I want to. That's why I made the switch. It's not these are not real. Also, it's working. The board I tested this yesterday, but yeah, I need to print the part. I already printed something. It's the first to try it with this. And I also will replace the 18650 battery. This is this one with the 18500. This is because this I could make then. The plan is to put it like this inside this. Make a housing where it is, and then it's reduced its size quite a lot. I think this would be great. Yeah, there is also this. You're wondering maybe what is this on the right side? You can control a second coil, and you can synchronize the coil or inverse synchronize it. So if you increase here the inductance, you reduce on the other coil the inductance. So I think maybe it is completely useless. I don't know. We will see. But I have the feeling for adjusting an antenna, this would be awesome, because then you're adjusting it, you see the microhenry, and when you know the microhenry, what you really need, then you build you're replacing this coil with the coil, also with a coil what you can let there forever. So this project is just a sneak peek. I'm still working on it. I'm not finished. And this is a quick and dirty video in one take. I only press a pause button. I will show you the next stuff. So the next stuff what I want to show you is this the project to make a 100 watts portable, portable under question marks, device transceiver, and I have this Yaesu 897 at home, and first I always need to figure out how I will do this, what is the best way to do this. And the first thing what I came up with is, there is this voltage problem, because this device needs 13.8 volts plus minus 15%, so 13.8 volts plus minus 15. This is what you find in the manual from the device. So and this turns out the upper voltage of this would be then, I believe it is 15.9 volt, something like this. So close to 16 volt. And I say, okay, no problem. Then I make a 4S, so I make 4 lithium ion cells in series, and three of them parallel. And then I get the maximum voltage too high. This would be then 16.8 volts, 16.8. One cell, has maximum 4.2 volt. Multiply with 4, you have 16.8 volt. And I said, okay, then the easiest way is I will just charge it only till 4 volt. 4 volt, then 4 times 4 is 16, then I'm 0.1 volt over this limit. I don't think this would be a problem. But there is something, so this seems like it's not a good idea, and I will tell you why. Because I have the ability to measure, I have so electronic load at home, and with this I can measure the capacity of the batteries. And what I did is I tested how much capacity I'm losing if I charge only till 4 volt instead of 4.2. I thought I will lose maybe, I don't know, 10% or something, 15% maximum. But in reality, this is much worse. You are losing minimum 30% of capacity. Also, I made a test. If I charge it up to 16.8 volt, I get out of my pack 231.7 watt hours. This is a 21700 cell, also 21700 cells. One of them has 5330 milliamps theoretically. So this is a lot, 231.7 watt hours. But if I charge the same, also the same pack, only till 16 volt, I got only out about 164 watt hours. So this is, I think in this case, this is nearly 40%. I made this 2 times and the values was different. And then I said, okay, I want to know this now. And then I made a test only with one cell. And here it was a little bit better, but still. So if I charge one cell full, I got out 19.3 watt hours. By the way, I'm using always watt hours. This is, in my opinion, the correct way to do this, because this milliampere, there is no, the voltage is changing, this dropping, so you should make this always in watt hours. So the full cell has 19.3 watt hours, and if I charge it only till 4 volt, I got 13.4. So this is 30% less than full charged. And this is too much for me. So I decided I will change the pack to 3S. So then we have this the problem from the under voltage. I'm not sure now what this is. So 13.8 volts minus 15%. How much is this? 1 second. So 11.73 volt would be then the lower limit from the device, from the manual. And someone for me was so nice, and who also has a FT897 at home, and measured the power output with different voltages. And this is what he got. With 10 volt input, the device still produced 90 watts. This is, by the way, the maximum what he can do. He not gets more than 90. 9.8 at 9.8 volt he gets out 80 watts with 9.5 volt input. Also this is already below the what the manual says. He gets 60 watts outputs, and so on. And you see here is quite a drop from 9.3 to 9.0. He gets only out 30 watts. 9 volt would be then, if I have 3S in series, divide with 3, you have 3 volt. Also 3 volt per cell, this is where you usually stop discharging the pack. So you have this range here, what looks very promising, I have to say. But I need to check this by myself to look if there is if something is heating up, because if you for example have a too less voltage on a gate of a MOSFET, he's not switching through and then it's getting hot. I don't know about the circuit if this can be the case on this device, but what I want to do is I make the same test and look with the infrared camera if something is heating up. Yeah, this is what I do. And if this turns out that everything is okay, I believe this will be the case. Then I built it in 3S, and I already rewired the pack to 3S. This is, by the way, much simpler to make, or also this is awesome. So you have here 4 cells parallel. Here you have 4 cells in parallel, and here. And you just, you have here the plus, you have here the minus, go here to this end, then you have here the next minus, and this goes to the plus from this, just here the connection. And yeah, and the minus in the end is from here. So go minus here, here, plus, minus, plus, and yeah, this is for the BMS. So these are made already. This bag, by the way, fits awesome. As this is like it's made for this. It's like the ISO Neo, this type of battery will come out. So 21700. This is the way to go, guys. Because this bag fits perfectly in this FD897. And here I have a space, so theoretically 4 more cells would fit, but I need to make a PCB with the battery management. I also will make, I plan to make a circuit what switches automatically between the input from here and the battery pack. So if you connect here a voltage, he always takes the juice from here, and if this is gone, he's switching automatically to the battery pack. So this is what I want to do. There would be also a way to just wire it different, that you go here in, go to a charger circuit first and to the battery, and the battery is always directly connected to the input of the device. But these are not. I think I don't want this, because this should be a add-on, and if I not use this battery pack, it should behave like it was. So yeah, I also want to include here a charger circuit on this PCB, so there will be a BMS. Then this circuit would switches automatically, and the charger circuit for this battery pack. There will be an external input for charging the battery. So this is the plan, at least. The only thing is, this is getting really heavy. But I mean, yeah, I showed you already. This is the wall thicknesses from this CIA. So this is so insane that I even start to like it. 11 millimeter. Oh no, not 11. A little bit over 10 millimeter at some points. This is crazy. This is so strong. This the hydraulic press channel should make a transceiver test. I think this will be on top, the FD897. So I think this is what I wanted to tell you. These are the 2 main projects I'm working on. Yeah. Third one, by the way, is if you because my antenna from the screwdriver control box has a temperature measurement, and I always get the measurement. So how to explain this easy? I have here a box. No, this is the box. This is my digibox. He's connected to my icon, and on this icon is the screwdriver. And this device, this box here, is asking over Wi-Fi the temperature from the controller box. And on this device also runs GS8 call every day, 12 hours, automatically start and stop from 10 in the morning till 10 in the evening. And I'm sending the temperature data now 3 times per day from Vienna. So if you get this message, this is me. I'm sending it on on the standard GS8 call frequency, 7.78 megahertz. I believe 10 o'clock and 5 minutes should be the first, as this is local time here in Vienna. Then the seconds are every 5 hours, I think. Then I think 14 or something. Then 11, 12, 1 or 3. I think 3 or 5. Something like this. And the last one I think is 21:05. What I'm writing here. 21:05. I'm sending my temperature data automatically from my antenna. So this is all what I have. Wish you a nice weekend and keep your projects going too. See you all.